Well, good evening, and welcome to Kopernik Observatory. I love a full crowd here. This is great. Welcome. My name is Drew Desker. I'm the director here at Kopernik, and who's here at that knowledge collection? Not everything we do this on a Friday night is necessarily astronomy based, although tonight happens to be, in fact, astronomy based. We've actually had people talk about the physics of music. Why does a violin, a trumpet, and an oboe all sound different playing the same note? We've had Stan Whittingham, the Nobel Prize professor from Binghamton University, talk about his work developing lithium-ion batteries. So there's always something to see up here. Now, back in March of 2020, we had to shut down because of COVID, and but we said, okay, well, we'll just shut down for a couple of weeks, let this thing blow over. That didn't quite work out that way, and so we still had all these speakers lined up for our Friday night's program. So we decided, why don't we just put it out on YouTube? So we actually had the speakers zoom into us here. We then turned it around, put it out on our YouTube channel. We now have over 13,000 subscribers on our YouTube channel, and now even though we're having people back, back live, if you will, we still are doing live streams. In fact, if you go to our website, you can actually go to our website, our YouTube channel, and again you'll see what's coming up. So we have tonight's program that's coming up, and then afterwards Jeremy will actually do an observing session with an all-sky camera here. But you can actually go back to our previous programs that we've had in the past. Actually, they're live here. Yeah. So we had talk about the James Webb Telescope, about the DART mission. We've had Time as a Rocketeer, as Les Bradshaw talking about him being working on model rockets. So even if you miss our Friday night program, you can still come back and see it. Oh, well, you're very welcome. We really do enjoy doing that, and we actually it was interesting because when we first started to do these live streams, people would put in the chat. We'd be talking back and forth, and then we would finally have people back in here. We actually get to finally meet those people that were otherwise on the chat. But we actually have people from literally around the world. Very often, actually, there's often this person from Adelaide, Australia, that's actually watching Saturday afternoon from Australia, our programs. But anyway, why don't we move into tonight's program? We're very fortunate that again tonight's skies are going to be look like they're going to be pretty clear. The moon is coming up very, very late, which makes these meteors going to be a lot more present to us. And somewhere is my speaker. Okay. All right, very good. Yeah, we've sort of got a full house here. We've opened up another room, our physics room, so that people that have come a little bit late will still be able to participate. But anyway, we're very fortunate to have on staff here Jeremy Cartie. He actually started out as a high school intern, and then became a teaching assistant, teacher, and now he works for us full time in a number of capacities. One of which is as an educator, but also our Livestream astronomer. And he is your presenter tonight for Comets and Meteors. So, Jeremy, take it.
Thanks so much. Switch it. There we go. Forgot. There it goes. Okay, so yeah. Hello, everyone. Hopefully we're in for an exciting night with some clear skies, maybe some meteors heading our way. And hopefully we end up with some clear skies this weekend as well, as we'll talk about. The Perseid Meteor showers peak this weekend, but there is some room on either side of the peak to spot some. In fact, even last week we were spotting some meteors, a few of them in a pretty hazy sky at the time. Last week was not great, so we'll see what is in store for us. But my goal tonight is to kind of describe and explain how meteor showers work and their sources. So let me jump into this here. So yeah, we're talking comets and meteors, and these are the main components for a meteor shower. So we got to talk about both of them. This graphic here shows you some examples of some illustrations of what you could see in the sky. Some of them are comets, some of them are meteors, and maybe by the end we'll take a closer look at this and you'll be able to tell which is which. Or maybe you already know too. So, carry on here. So talking comets first. All right, so I'm starting off with one of our best images here at Kopernik. If you had the chance to tour the building either in the past or today at all, you may have come across this one. This is an image taken here at Kopernik by the Astronomical Society of Comet Hale-Bopp from 1997. Maybe some of you got to see this one in person, in real life. And from all the stories I've heard, it put on quite a display. It was a super bright comet, a magnitude -1.8 if I recall, and visible to just your eye over the course of several months, over a year. So the picture we have here from what I've been told, has shown up in a couple of textbooks in the past, which is pretty neat to have one of our images there, showing up in an official capacity. But more than that, it does display the two large features of a comet that's entering into the inner solar system, and that is the ion tail and the dust tail. So, oops, sorry, let's go back. Let me try something here. I just want to see if I can get my notes to show up properly. There we go. Well, I guess the trouble with that is it's gonna do here. Let's do this. Bear with me a moment as I extend the displays instead. Keep changes. And we'll drag this over to this side. There we go. Okay. That's what I need to see. So, Comet Hale-Bopp, there it is again. So we have our blue ion tail, and that tail is composed of ions. Around the comet, around the nucleus of the comet, the actual solid part, is a coma, kind of an induced atmosphere. And as those gases are hit by radiation pressure and the solar winds, you get this energized ion tail of plasma, and this one is glowing a nice blue. So that's the ion tail, and that does point directly away from the sun. The dust tail, on the other hand, is exactly what it sounds like. It's made up of dust coming off of the comet, again, being thrown off by radiation pressure from the sun, and those particles do not get carried away as easily from radiation pressure and the solar winds. So they exit off the comet at a slightly different angle, not directly away from the sun. So that's our comet Hale-Bopp. We're going to go through a few comets here. There it goes. So next we have this more recent comet. Now, Comet Hale-Bopp was an example of a super bright comet, visible to the eye, no telescope or binoculars required. This one here was just on the cusp of naked eye visibility. So really it was best viewed through binoculars or a scope. Now, back on February 11th, there was a close approach of this comet, C2022 E3 ZTF, to Mars. so that you could capture them in the same field of view. And what I like about this image is the kind of play of color. You do see the redder hue, the warmer hue of Mars on the right-hand side of the image, and on the left-hand side you see that green color popping off the comet. So sometimes with comets you'll see this influence of diatomic carbon being energized by the sun, and that's why we get that green coma around the nucleus. So this comet was, if you're familiar with astronomical brightness and magnitude, it was a magnitude 6. So again, that's just on the verge of human vision. Anything dimmer than that, you can't see without a scope or binoculars. All right. So it really did look like this comet throughout the night was flying by Mars. But in truth, they were millions of miles away. So I have a video here that does show you how comets move through the solar system in one night. Now, this footage is from a few hours worth of data, but we may reference that term again in a bit. But astronomical units, that's the 1 AU, is the shorthand for that, is the average distance from the sun to the Earth. So we're talking beyond 2,000 Earth-Sun distances. That's where the Oort cloud lives. So these and our dry ice. So let's make a comet. In this bag, yeah, I have some dry ice. Dry ice is frozen carbon dioxide. The gas we breathe out, if we freeze it down, we get something that looks quite a bit like snow. So in times when we have blackouts, you may end up getting some dry ice to keep your food cold. And I have to wear gloves because we're getting really well below zero on this ice here. It's not like water ice. This is way colder, and if I touch it, it will give me almost immediate freezer burn. So I gotta be extra careful with it. If it just quickly glances your skin, it's not a big deal, but that's why I don't necessarily too concerned about wearing sleeves. But yeah, you wouldn't want to eat it. That'd be bad. So I'm just going to get this into more of a snowball. All right, now we got some more ingredients. It's not just dry ice. Nope, we're not going to do that. We need to add some gravel, dust, and sand into this mix. Do one more little scoop here. And now some iron. So in here we have metallic iron in just iron filings, just particles of iron. We're going to dump in here. Just a bit of iron. Then we add some nitrogen. So this is just some ammonia cleaner. NH3, if I recall. 1 part nitrogen, 3 parts hydrogen. Now we need some hydrocarbons. Hydrocarbons like sugar. Sugar is a hydrocarbon. Now these are nerds, and at one point they were edible, but they've been in our comet kit for some time, so we just use them as hydrocarbons. And hey, well, you know what? We got some sprinkles here too. How about a variety of hydrocarbons? Yep, some extra sugar. Okay, now what I'm going to do is first do my best to mix this around a little bit before adding our last ingredient. We got one more here. We're squishing it, yep. Right now I'm gravity, and I'm compressing these materials down.
I think you check it everywhere. Yeah, like maybe just like spin in a circle and then get dizzy if you are holding it out.
Mixing up the dry ice and all of our ingredients.
Can I have some sugar though?
All right, last ingredient we need is a bit of water. So we'll dump our water in now. And you can see that effect. Now, when we see this smoke billow off the dry ice, that actually is water in the room immediately condensing around that cold carbon dioxide that's vaporizing. So we're really just seeing water there. We're not seeing carbon dioxide itself. Let's bring some of this material. We got some trapped. There we go. All right, now we'll compress this all down and see what we get. And what we're trying to get here is hopefully, now it feels more in my hand right now as a rubble pile, which is a type of asteroid. Just not exactly what we're going for. My hope is that there is something solid right at the center that we can use as our comet once I compress it enough. But we'll see a rubble pile asteroid. And we'll also talk about the differences too. My hope. Wow, it's very crumbly, our comet today. But the likeness is appropriate. And what we can do as I come around with our comet, it ends up looking very much like a dirty snowball. And notice the tail that comes off of it as well. If I put energy into this comet, like the solar radiation from the sun, we get the tail of the comet blowing directly away from me, right? Like the ion tail we saw earlier. So we'll come around and again show you the likeness of it. I'll come down the lane here. It is just, that's all a comet is it's dirty snow, but not regular snow. You're talking dry ice. So we're not going to touch this snow. It's too cold. In fact, I'm starting to really feel it through my glove. My glove's probably getting pretty brittle at this point. Yeah. So a comet made here on Earth, but made of the right stuff. Okay. Now don't worry, stay tuned. I do have something from space that you get to hold today.
I give up for a game.
Oh yeah, that's solid now. That glove. All right, we're gonna wheel this over here.
We get to try what?
All right, we're back online. Good news.
Yeah. Oh, we see the Millennium Falcon. No. How's the Millennium Falcon in there? You're right. It's called Red Claw.
Okay, so we talked about that from our Oort cloud. That's where comets come from. And now we're going to move ahead to our next comet example. We saw Comet Hale-Bopp, we saw Comet ZTF, and now we're going to see a even more recent comet. This here is Comet 12P Pons-Brooks. And this comet recently in July, streaming. Yes. So we'll see if that helps. Now this comet this image of the comet was taken by